Okay, hello everybody. This is Mr. Berto. Can't believe I'm actually making a YouTube video to teach calculus. This is unprecedented right here. But I hope everybody's safe and healthy and happy with their families. And just a quick little lesson today. If you download the materials at the bottom of my webpage, okay, you got a little formula sheet here as far as formulas you need to know for an upcoming quest that we're probably not going to have, but certainly the AP exam. So just as far as these formulas are concerned, just a couple you shouldn't worry about, but 1 through 6 you should know. It should be all very familiar derivatives for you, and also the integrals as well. The chances of you having to integrate something like secant squared on the AP exam, probably pretty low, but remember, that's somebody's derivative in there. Whose derivative? The answer's derivative, okay? So something to think about. You know, 7 and 8, if you don't know the derivatives and the corresponding integrals, then that's a little crazy by now because we talked about that a lot. But if you actually look at, this piece over here, try to remember if you want to integrate a quotient, the bottom's not being raised to a power, you could take the derivative of the bottom, okay? And if the derivative of the bottom matches the top, the answer is going to be ln absolute value of the denominator plus c. And if you can multiply the derivative of the bottom by some constant to create the top, put that constant in front, ln absolute value of the denominator plus c. You know, as far as the trig inverse derivatives, don't forget this one right here, by the way, a to the u. Okay, something you've seen before. You don't always see it on the AP exam. It's not so easy to remember. As far as the inverse trig derivatives, please don't worry about the derivative of cosine inverse, and don't worry about the derivative of cotangent inverse, or secant inverse, or cosecant inverse. Only focus on sine inverse and tan inverse, and also their corresponding integrals as well. Not that I really suspect you've seen it all that much on the AP exam. You know, if you go to the back of the ditto, okay, these are lesser known integrals, 16 and 17. We did them earlier in the year. They're actually ln's after you put them in quotient form. Tangent, not so easy. You know, the derivative of cosine u with respect to u would be negative sine u. You need to multiply that by a -1 to create the top, okay? And then right here, some people would take that -1, making an exponent of the argument of cosine, make an exponent of the argument of ln, pardon me. So this would be cosine u quantity to the -1, same thing as secant u, okay? I don't think you really see these all that much, but it's possible. And wipe out 18 and 19, no longer in the curriculum. We're not going to talk about them. Don't forget about average value, okay? Something we've spoken about recently. And the derivative of the inverse, okay? So that's what we're actually talking about today. You know, they'll give you a function. They'll say g of x is actually equal to f inverse of x. There's a formula for this. I think it's easy to actually do the setup for the formula first, which is g of f of x. Try to remember the two most important things. Well, that's disgusting. About inverse functions, okay? And that is that they cancel each other out. And you also interchange x and y. So if they cancel each other out, if g is really f inverse of x, this is really f inverse of f of x, they'd cancel each other out, you'd be left with x. And that's the starting point. Okay, I want you to start there for the formula. And now we're going to get a little abstract chain rule practice when we take the derivative of both sides. You know, if you want to take the derivative of g of f of x, remember, if you want to take the derivative of a function whose argument is not one single x, you got to use the chain rule. I don't know if you hear my kids running around like crazy people upstairs, but try to ignore it. Anyway, so if I take the derivative of g of f of x, we're going to start with g prime of f of x. Take the derivative of the outside function, rewrite the inside function, then multiply by the derivative of the inside function, and the derivative of f of x, f prime of x. And the derivative of x with respect to x is equal to 1. Okay, and look, they're going to want to find the inverse evaluated. The inverse is derivative evaluated at some value. So they're going to want like g prime of 6, something like that. Here's g prime of f of x. Let's isolate it, divide by f prime of x on both sides. And we get g prime of f of x is equal to 1 over f prime of x. And that's really the formula right there that we're going to use to take the derivative of an inverse. Some people like to memorize it. I think it's okay to memorize the start right here, get a little abstract chain rule practice, and derive the formula. Quite literally, derive the formula. I can't do the British accent as good as Ava, but I know she's doing it at home right now. And if you actually take a look at those materials posted on the bottom of the website, you get some problems. So we've now reached the part of the lesson commonly referred to as mad problems, yo. Just kidding. We're actually just going to do some problems here. Okay, and sometimes there's more than one way. Here they give us f of x, they give us the function, and they want g of x. They're saying it's equal to f inverse of x. That's how we know it's a derivative of an inverse problem, because they want you to actually find the inverse is derivative evaluated at 7. Okay, and there are two ways to do this. I mean, there's a way, we'll call it method 1. And that's to just form the inverse, okay? You could form the inverse. Newsflash, on the AP exam, it's probably going to be impossible for you to be able to do that, okay? But, you can do it in this case. Remember, a function always represents y values. This is really y equals x cubed minus 1. Okay, and if you want to form the inverse, interchange x and y. And we're going to put that x is equal to y cubed minus 1. Okay, then we want to solve for y, because that y right there, that's g, okay? That's what I'm looking for. This original y right here was f. Okay, so when I solve, add 1 to both sides, x plus 1 equals y cubed. Then we'll get a little cube root action going. So the cube root of the quantity x plus 1 is equal to y. And then, when you want to take the derivative here, because that's g of x, okay, so you could either say g of x is equal to, I'll write it x plus 1 quantity to the 1/3 power. That's what a cube root is right there. And now when we take the derivative, g prime of x is equal to, drop it like it's hot, the 1/3, rewrite the x plus 1, raise it to the 1 less, so 1/3 minus 3 over 3, what is that, negative 2/3. Don't forget to multiply by the derivative of the inside, even though if you did here, no big deal, because it's just equal to 1. So here we end up with 1 over 3, and then we have x plus 1 quantity to the 2/3 power. So that's g prime of x right there. And look, if you could form the inverse, you could just simply take the inverse as derivative. Now you want g prime of 7. So evaluate this puppy right here. At x equals 7, and we get 1 over 3 times the quantity 7 plus 1 to the 2/3 power. And that's really 1 over, 8 to the 2/3, really cube root 8 right there is 2 squared. You get a 4, and 3 times 4 yields the desired result of 12. So 1/12 is actually our answer there. And not the way you're going to be able to do it on the AP exam, okay? You're not going to be able to actually form the inverse. So let's talk about the second method here. So this will be method 2. And that's use the formula. Use the formula. If you're a Jedi, you could use the Force, but most of us have to use the formula, unless you're really a secret Jedi in disguise, but I'm not allowed to tell you those types of things. That's what the council said. Okay, so anyway, the formula here, always put the inverse on the outside. So g is the inverse, okay? So start by writing g of f of x. That's got to equal x, okay? You can pose inverse functions. They cancel each other out. So this guy right here, he's the inverse. You could put the g on the inside and the f on the outside. It's another way to do it. It's not a formula that's quite as useful as this one. It is an option, okay, but this right here should really suit your purposes. Take the derivative of both sides, little abstract chain rule action. G prime of f of x times f prime of x is equal to 1. And some people even go right to this step. They say g prime of f of x is equal to 1 over f prime of x. Okay, and look, this is the formula. But look, I want g prime of 7. I don't want g prime of f of x, okay? So I want that whole f of x to equal 7. You might want to write that down over here and be like, okay, we want f of x to equal 7. We need to know the x value that generates f of x equal to 7 here, okay? Because I want to take that x value, I want to put it right here. And then I'm going to end up putting it right here. So look, sometimes they're just going to tell you what this is. You'll see that in the next example. But up here, you could see that, if you want f of x to be equal to 7, you got to do a little guesstimation, okay, as far as plugging numbers inside there. And you can see if, make x equal to 0, you get f is negative 1. Make x equal to 1, you get that f is 0. Maybe if x is equal to 2, and you'll see here, okay, then f is going to be equal to 2 cubed plus 1, which is going to give us that 9 right here, which is actually not what I want, right? 2 cubed minus 1, that's a little bit better. It's a bit better. So that's going to give you 8 minus 1, which is going to give you 7. And that's what we're looking for, okay? So look, what did I just write over here? Basically, now we know that f of 2 is equal to 7. And that's the information I'm going to use right over here, okay? F of 2 is equal to 7. That means for f of x to be equal to 7, x has to equal 2. And you take that information right there, and you're going to replace this x with a 2, all right? And when you replace this x with a 2, you also go and replace that x with a 2. So you're really going to end up with g prime of f of 2 equal to 1 over f prime of 2. Right now, people are like, g prime of f of 2, that's not what I want. I want a g prime of 7. Well, f of 2 is equal to 7, okay? So this is really g prime of 7. That's the slope y'all are looking for, all right? And that's equal to 1 over f prime of 2. People are like, well, how do I get f prime of 2? Well, stop complaining and derive, okay? You could easily get that f prime of x. You can't see what I'm writing here, but we know it's equal to what? 3x squared. All right, so that's what I put right down over here. So we know f prime of x is 3x squared. So f prime of 2 is going to be 3 times 2 squared, which is equal to 3 times 4, which is really 12. And you see we end up with 1/12 down here. Okay, the same thing that we got before, okay? I'm sure you hate this method. Usually people do when they first see it. All right, remember these videos, if I'm moving too quick, okay, you can always pause and take a look, all right, at what's going on. We're going to do another problem right here. You're going to have to use this formula on the AP exam. You know, you want to talk about the 2003 AP exam. Okay, here's the problem right here. Let f be a function defined by f of x equals x cubed plus x. Then they tell us that g of x equals f inverse of x. So they're kind of setting you up for a derivative of the inverse problem. Then they tell you g of 2 is equal to 1. You know, remember, g of 2 equal to 1 means the point 2 comma 1 lies on g. And if you think about it, okay, when you take inverses, you know, besides them canceling each other out when you compose them, you interchange x and y. So really, if 2 comma 1 lies on g, that means 1 comma 2 has to lie on f, because g is f's inverse. And if 1 comma 2 lies on f, that means that f of 1 is equal to 2. So that's really the information they're giving you here. If g of 2 is equal to 1, that means that f of 1 is equal to 2. Hopefully that makes sense. What do you guys think? You know, thumbs up, thumbs down, sideways thumb. You better all be voting at home. And then they want g prime of 2. And remember, g is the inverse, okay? So now they want the inverse's derivative evaluated at 2. That's how you know it's a derivative of the inverse problem. Then you're like, oh, I'm going to form the inverse here, you know, and if y is equal to x cubed plus x, I'll make it x equals y cubed plus y. Yeah, good luck solving for y there, Poppy. It's not going to happen. And sometimes they don't even tell you what f is equal to. They'll just give you some abstract function, f of x, and they'll tell you g is the inverse, and they want g prime of 2, something like that. So you're not always able to form the inverse. So remember, g is the inverse right here, right? They tell you g is the inverse of f. So let's start with g of f of x is equal to x. Okay, and then derive both sides, and I'm going to get that, you know, g prime of f of x times f prime of x is equal to 1. All right, now we do a little division action here. Okay, and we get that, you know, g prime of f of x is equal to 1 over f prime of x. Sorry about the shadow right here. My phone is casting it. It's probably really annoying you, but there's really nothing I could do, you know, because I'm going to end up writing in the shadow at some point. So hopefully it's not too bad. Stop complaining, okay? We're learning online right now. Hey, and they don't want g prime of f of x. They want g prime, where is it, of 2, okay? 2! So I want this f of x to be 2. And then you got to think to yourself, you could be like, you know, so what's the x value? Because I need to know what x value to put there so I can put it there and get my answer. So what's the x value I plug into f to generate back a y value of 2? You know, let's see over here. F of x equals 2. I wonder what x could equal. How about 1? All right, and look, they'll give you stuff like this. They told you the information here. If g of 2 is 1, that means f of 1 is equal to 2. So it's not even like the previous problem. Previous problem here I need to think about, right? What could I plug back in to get a 7 back? It's usually not like that, okay? It doesn't work that way. You know, usually they straight up end up telling you things. Remember now, x is equal to 1. So replace this x with a 1. So we get g prime of f of 1 equal to 1 over f prime of 1. And you get somebody like, well, I didn't want g prime of f of 1. I wanted g prime of 2. But f of 1 is equal to 2. Okay, so now we really got g prime of 2. That's what we want. Is equal to 1 over f prime of 1. Well, now you're like, okay, well, I actually have to find f prime of 1. Shouldn't be an issue here to find f prime of x. We know it's going to be 3x squared plus 1. All right, and that means that f prime of 1 is equal to 3 times 1 squared plus 1. So that gives us 4 right there. Thus, g prime of 2, sorry, I think I was missing a parenthesis there. Thus, g prime of 2 is equal to 1/4, okay, which you can see is our answer right here. So it looks filthy, but it's really not too terrible to take the derivative of an inverse function. So that right there is going to conclude this video for today. There's actually another problem down here. I don't know if the solutions are actually included for these problems right here. Okay, so let's do number 2 together, and then we'll call it a day. And don't forget, there's a little review ditto for you to print out as well that has the solutions on it. Okay, and that's a review ditto for a quest that's probably never going to end up coming. But remember, it's all about the advanced placement exam, okay? You know, I hope everybody's home and safe with their families. You know, we're trying to get by best we can. They might end up moving these advanced placement dates. Let's hope that happens. But, you know, when we finally get back to normalcy, I want you guys to be able to rock and roll, okay? So one more problem. You know, right now you could even stop this video. You could try number 2, okay, a little homework action right here. 1 is cute. I mean, you could form the inverse, or you could use the formula. If you don't know the inverse of f of x equals ln x is g of x equal to e to the x, then you all been living under a rock anyway. So let's do number 2. You know, long division right here, but you'll see that as well on that review ditto, I think, okay? So you gotta know how to do one of those problems as well. But number 2, they give you f of x equals a quartic right here, x to the 4th minus x cubed plus 3. And they tell you g is the inverse of f, okay? It's usually g that's the inverse of f. They might tell you f is equal to g inverse. Just switching those letters right there can really mess with people's formulas. But it's really not too terrible if you just think about the letter switch. Hey, g of 3 is equal to 1. That immediately means that f of 1 is equal to 3. Okay, and what's g prime of 3? So they want the derivative of the inverse evaluated at 3. You know, if you want to start with g of f of x equal to x, be my guest. Seen an AP problem, it'll show up on your review ditto where they didn't even tell you g and f were inverses. They just told you g of f of x is x and f of g of x is equal to x. That implies that they're inverses because they're going to cancel each other out when you compose them. But regardless, you know, if you want to just go to the formula, it's going to be g prime of f of x equals 1 over f prime of x. Remember, I don't want g prime of f of x. I want g prime of 3. So really, you know, you want to know the x coordinate that generates a y coordinate of 3 on the graph of f. So they want f of x equal to 3 right here. And once again, you know x is equal to 1. Okay, they straight up told you that information. So that means over here, really just looking for g prime of f of 1 equal to 1 over f prime of 1. And I've seen problems where, like, straight up in here in the information, they'll tell you what f prime of 1 is. Maybe they make it totally abstract. They don't tell you what f is. They tell you f prime of 1 is 5. You know your answer is 1/5. Okay, it can happen. But regardless, here we'll have to do a little bit extra work. G prime of f of 1, we know f of 1 is 3. And that's what we wanted. Okay, g prime of 3. So that's just 1 over f prime of 1. Let's derive, okay, and get that f prime of x is equal to 4x cubed minus 3x squared. And that means that f prime of 1 is going to be equal to what? 4 minus 3, which is 1. So really g prime of 3 is just going to be 1 over 1, which is indeed equal to 1, all right? As long as I didn't make any silly mistakes anywhere or anything like that. You know, if you notice any mistakes on these videos, please let me know. Give me an email, okay? First time I ever did this. I don't know if any of that made sense to you whatsoever. So at some point I'll put this up on YouTube and you could take a look, obviously. So you'll be watching it now. Probably comments are disabled on the video because I'm not an idiot. Anyway, once again, the priority right now is that you're home and safe with your families, okay? And remember, we will get through this here, you know, and next week is really supposed to be vacation, so we're not supposed to be doing any new work. But after that, we're going to be rocking, we're going to be rolling, we're going to be out of controlling. You want your AP Calculus information, you're going to come right here, okay? And we'll get you guys prepped where you need to be. And once again, stay healthy and stay safe. This is Berto signing off, y'all.